Hi, welcome to atomic mass practice. We've been talking about atomic number and the fact that it's on the periodic chart, and we've said that the atomic mass is on the periodic chart, and we've had the definition. We said that the atomic mass is the weighted average of all of the naturally occurring isotopes of a particular element. So we've done some in class and we've done some for homework, but what we're going to do is I'm going to do one more on a video so that you can pause me and do whatever you need to do to make this work. So magnesium, that's what's on the board. Magnesium has three naturally occurring isotopes. There's magnesium 24, magnesium 25, and magnesium 26. Each isotope has its own particular mass. So that's one of the ways Dalton was wrong. And we said that atomic masses, for right now, we're going to measure them in atomic mass units. And we have used AMU as the abbreviation for atomic mass units. You can also use a lowercase u. So for each isotope, 24, 25, 26, I've put the individual mass of the isotope, and then this is called the relative abundance. Relative abundance. I'm not sure I use that in the notes or in the PowerPoint, but it's the percentage of that particular isotope that appears in nature. And so what I'm going to do is, just like we get your weighted grades for your chemistry grade, you take 60% is your test grade. If you have an 80% on all your tests, you take 0.8, you turn the percentage into a decimal, and you multiply it by the possible 60 points that you could have towards your grade. We're going to do the same thing here. These are the masses, they stay like that. These all become decimals. So you take each one of the percentages and you change it into a decimal. So this is going to be 0.7870, keep the significant digits. This is going to be 0.1013, and this is going to be 0.1117. And so this is the percentage of that mass that I need to figure out. So for each one, I'm going to take the 23.98504, that's the first one, multiplied by the 0.7870. And one thing I should mention is, because most of the isotope is magnesium 24, chances are good that the atomic mass is then going to be closer to that mass. So I'm going to take, like I said, the 0.787, and I'm going to multiply it times the 23.98504. And for the first isotope, if I can use my calculator correctly, I'm going to get 18, and now I can keep 4 significant digits. So 18.88, and that's atomic mass units. That's the part that is the first isotope. I do the same thing for the second one, 24.98584, and I multiply it by 0.1013. I keep 4 significant digits. And I do the same thing for the last one, 25.98259. I multiply it by 0.1117, the decimal that is the percentage. And then I add them all up, just like I add up your grades for the percentage that you get for each thing that I grade for you: homework, lab reports, tests. It's just a test count more, just like this first isotope counts more. It appears more in nature. So when I add these up, 18.88 plus 2.531 plus 2.902, I get 24.31. Probably should leave it like that. And if I check on my periodic chart, that's pretty close to what it says on the periodic chart. So that's how you do the weighted atomic masses. That's how they got all those numbers that are on the periodic chart. It's the naturally occurring isotopes by their abundance, by how much appears in nature of each one.